In this video, we will talk about text and strings in C++. So far, we have only covered numerical variables and data structures, like integers, doubles, and vectors of integers and doubles. Non-numerical text has just been output on the screen without storing it in variables so far. In the C++ standard library, there is a data structure called the string for holding text. Strings are in some ways like a vector, but we don't need to specify what data type a string holds. There are also C-style ways of dealing with text, but we're not going to use those. Except later at the end of this video, when we look at standalone programs and passing arguments to a program. And this has to be done using C-style strings. Here's an example of code for strings. First, we need to include the string library header file. So we do that using the command include and then string in angled brackets. And then, of course, we also include the IOStream and namespace libraries. Then, in the main function, we can declare a constant variable of the string type and name the variable s, and then initialize the variable to the value hello, world, and put that inside quotes. And then if we try to see out that variable, we're going to get hello world displayed on the screen. So this is an example of how to declare and initialize a string. So a string is essentially a string of characters. That's a sequence of characters that forms a phrase or a sentence. Anything that's in between those quotes. One can also apply certain functions, for example, to join strings. There are many functions for string manipulation, but we're just going to mention a couple here, as our focus is on numerical computing. For example, we can append one string to another using a plus symbol. Here I have declared a string h called hello, another string w called world, and then I can combine those two by using h plus w to define a new string s. And then we can display that to the screen. Now, of course, if we run this program, let's type it up in Xcode here. I have defined h, w, and then I'm simply printing h plus w on the screen instead of going through the intermediate step of defining a variable string s equals h plus w. I'm just displaying h plus w on the screen, and I'm gonna get hello world. So that joined the two words, hello and world. If we want a space between those two words, we're gonna have to include a space either after hello or before world. So let's include a space here and run it again. And then we get hello space world. We can also apply functions to strings. So to do that, let me first define the string s, which is s or h plus w. And then we can apply the function, for example, size, onto that string s. So to do that, the standard way to do that in object-oriented programming is to apply the size function onto the object s by saying s.size. And then parentheses. So if we run this program, we're going to get the size of this string s, which is how many characters are included in hello and world. So it's 5 characters for hello, 5 characters for world, and 1 for space. So we get 11. So that's the size of this string. We can also compare strings by using the equals character to check if 2 strings are equal to each other. This will return true or false. And if we want to assign one string to be equal to another, we use the equals character. We can also define a vector of strings. Now, a string is a data type, so we can have a vector angle brackets string and access the elements like in the same way as we did before for a vector angle brackets double. So here we declare again a string h that is equal to hello, another string w that's world, and we can declare a vector of strings v, and then we can add elements to it. Here we can do it using the pushback command that we discussed earlier. So this v.pushback h will add the first string to the vector v as the first element, and this second command v.pushback w will add another element, the next word, to the string, and then we can print out each element to the screen by using the cout command inside a for loop. So for I equals 0, we'll get the first element, which is hello, and for I equals 1, we'll get the second element, which is world. And this will print each element of v to the screen one after the other. Now let's talk about a slightly different topic, which is creating C++ programs. C++ is written in one or more text files. That's what we've done so far. We've written it in CPP files, and one can also write C++ in header files like H or HPP files. When we build the code, we turn these files into a program that can be run on its own or can be called by another program. On Windows, these are files that end in a .exe extension. So that stands for executable. And there are different conventions for file names on Linux and Mac OS. So this is what happens when we create a program. When we write a CPP file, potentially calling or using some header files, it goes through a preprocessor which compiles it and then creates an object file. When we run that program, the object file and potentially the library files that our object file may call are linked and are linked together to an executable. And that leads to a program, an executable program that we run. So, for example, in Visual Studio, we can select build and then build solution, or we can press Ctrl, Shift, and B. When that happens, we are creating an executable file. That's our program. if we go directly to the solution folder by right-clicking on the solution and then clicking over Open Folder in File Explorer, we are going to go directly into the folder where that executable is. We can also do that here in Xcode. The File Explorer has disappeared here, but to bring it back, I can click on this button right here, and this will appear here, or I may have to also press this button. But I can see my CPP file here, and under products, I can see my executable file here. And I can right click here and click Show in Finder, and I can find that executable file. You can do the same thing. So this is a Unix executable. You can do something very similar in Visual Studio. The only difference is you right click on the solution and click Open Folder in File Explorer, and you will find that executable file. That executable file in Visual Studio is in the debug folder if you use debug mode. So here we are in Visual Studio. I have created a Hello World program, and I can see here in the Solution Explorer the CPP file that I created. And if I go here on Solution and right click, I can select Open Folder in File Explorer. That will open the folder where I have saved this CPP file and the solution file. And by the way, if you want to open this program in Visual Studio, you should not open this CPP file directly, because you will get an error that this is not linked to a project. Instead, you should open the solution file, and that will open up all this solution with this structure, and then your CPP file will be included in a project and you can run it properly. Okay, so if I want to find the executable file, I can go into here and inside the folder debug, and I'll find some object files here and the executable file that is essentially the program is found here under this extension .exe. So the first time I click on this button on the Windows debugger, that will compile and create this executable. And you can also see the path here where this executable is located, and it's ran into this terminal in the command line. Okay, so far we have ran the program within Visual Studio or Xcode or CLion and so on. In Visual Studio we did it using debug and start without debugging, or with Control F5. The program, that is the executable file that we created, can be run separately. You can do that by simply double-clicking on this executable file, and that causes the file to run. There is another way to run these files using batch files. A batch file is a text file in Windows that contains a series of commands. These can include commands to run an executable file or program. The value of doing this is that we can pass arguments to the program when we call it from a command line or from a batch file. To take advantage of that, we want to write programs that accept arguments. We're going to show how to do that in a minute. So these batch files, the structure we're going to show works in Windows. In Mac OS and Linux, we have analogous file types that are called shell scripts. Okay, so we talked about how we want to write programs that accept arguments. So how do we do that? Well, so far we have written the main function without any arguments. So the argument list here is empty. So these parentheses here are empty. To pass arguments to the program, we need to change the form of the main function as follows. So it would look like this. Here, argc is an integer, where argc stands for argument count. This integer stores the number of command line arguments passed by the user, including the name of the program. So if we pass a value to a program, value by argc would be 2. So again, the value of argc would be 2. 1 is for the argument and 1 is for the program name. The value of argc should be non-negative. And here argv stands for argument vector. That is an array of character pointers listing all the arguments. If argc is greater than 0, the array elements of argv or argv0 in this case up to argv of argc minus 1 will contain pointers to strings. And we will see in a minute that argv of 0 is the name of the program. And after that, every element like argv1, argv2, and so on, up until argv of argc minus 1, every element after that is a command line argument. Okay, so here is an example where we're using the argument count and the argument vector. And I'm using an online compiler here called Coliru. I'm going to post the link to that below. It's a very good online compiler. And you can run the latest C++ 20 standard on it by changing this command. So this is running in Linux using GCC or G++, and here is the command line command to compile the program and then execute it. So this allows me to pass arguments to the program when I run it. So that's the way you would do it in Linux. There's a very similar way to do it in macOS, and in Windows you would use .exe here to call the program from a terminal or from a batch file. So here I have cout, and then you have entered, and then argc. That's the number of arguments, and then I'm displaying the number of arguments, and then actually I can put that here. Then I'm changing the line, and then I am printing the arguments that went into the program when I execute the program. So this starts from 0, and remember 0 will be the name of the program. So if I don't want to display that, I should change that to 1. But let's run it like that to see it. So then that for loop will print out each and every argument that I type when I call this program. So here the name of the program is a.out. So I can click compile, link, and run. If I do that, we get this message here on the terminal. You have entered 9 arguments, so argc is 9. And here, after the name of the program, I have typed, "Hi, how are you? Good, how are you?" So together with the name of the program, that's 9 arguments. And then each of those becomes a component of this vector argv. And the first one is hi, then how, then are, you, and so on. So this is how we can call a program using a vector of arguments. And then if we want to use these arguments inside our program, we can use argv and this vector argv, and then square brackets and I to access each component of the argument vector. So if I change that I to 1, just to skip the first argument, because the first one is the name of the program. Let's run it again. So now I just get the arguments that I typed without the name of the program. So I just get hi, how are you, good, how are you, and so on. Okay, we could do something similar using a batch file. I will leave the instructions here on this slide. So if we have built this program and our project is called, for example, lecture 11 or lecture 9 or a.out and so on, and it's in some location called c/cpp, then the executable file will be somewhere like inside that folder, lecture 11, and then debug folder, and then lecture 11. There may be an x86 or an x64 here before debug. We may have to go one level deeper. But anyway, the executable will be somewhere there. Maybe there's x64 here after inside that folder, and the debug folder will be inside there. And then to run this, and again, remember that applies for Visual Studio. So if you're using CLion or another IDE, the structure may be a bit different. But to run that program using a batch file, all we have to do is have write a text file, and inside that I can type the whole directory, the location of that executable, and then just the arguments that I want to pass into it. You could type what I typed before, or you could just type these numbers and so on. So in the example we showed here, you could pass any number of arguments actually. And then to create such a file, a batch file, we can go into that directory and right click and select to create a new text document, give it a name, and change the file extension from .txt to .bat. So that will become a batch file. And to edit that, I can right click and then choose edit, or I can edit it before renaming it. And after I rename it, it becomes a batch file, and if I just click on it, it will run. Or I can execute it from a command line. So when I right click and click edit, I can type in commands inside, and these are the commands I just described. Okay, so if the executable file and the batch file are in the same folder, as I described, then we don't need the full folder path. We can just write the name of the executable and then the arguments. In general, the syntax is that we have the name of the program, the exe files, and followed by any arguments to be passed to the program. So in this case, it's lecture11.exe and then 3.6 and then 9 and so on, or it could be some strings here that we want to pass to the program. Now, for this course, you don't need to know batch file syntax, but it can be very useful later. But remember, batch files are Windows specific. If you want to do something similar in Linux or macOS, you can use shell scripts. And finally, I will close with a couple of tips. You can create variables to avoid repeating typing the whole program name. For example, you can use set exe equals this. So you have this whole path where the executable is located, and set that equal to something. Let's name that exe. And then I can have, I can type inside the batch file, I can type %exe% and then the arguments, and that will run this executable, and I don't have to type up this whole string, this whole path. I can just use a shortcut for this when I want to run that executable. And finally, this is an example of a simple for loop that goes from 1 to 7 in steps of 2. So that's the basic syntax to do that. And that will run this exe file. And the arguments are going to be, the first argument would be 1.6, and the second argument will be from 1 to 7 in steps of 2, so that's going to be 1, 3, 5, 7. And that's it for this video. Thank you for watching.